Hey there. Let's talk for just a moment about calculators. Okay. Um, Maybe you've purchased one. Maybe you use one on your phone a lot. Maybe you've accessed free online ones. There's a calculator on your Chromebook. This is the type of calculator that I will use in videos. It's a really user-friendly one, and students find it pretty easy to use. So you'll hear me talk about this one a lot, but I will also link in there a free scientific calculator that's available on desmos.com. I'll link that in all of your assignments if you want to use it. And if you have any questions about how to use different calculators or anything like that, you can email me and ask me. I can usually figure it out. But this is the one that I'll use under the document camera often. What I want to talk a little bit about is because sometimes people have this misunderstanding that if you are using a calculator that somehow you're not as good at math, or that you should always use a calculator, and the truth as usual is somewhere in between. In real life, I use a calculator plenty to help remove human error. But in real life, there's also times so that I never use a calculator because it's so much faster just to do in my head. So we're going to talk as we go through the notes today. So you'll need pages 5 and 6 out of your math binder today. As we go through these notes today, we're going to talk about when is it reasonable to use a calculator and when is it actually more efficient to not use a calculator. Okay, so grab those notes, grab your pens, whatever you need for this, pages 5 and 6, here we go. So I've talked in lots of videos about how when it comes to mathematics, if you're doing it on the computer and doing digital assignments, we've got it set up to where you're showing all of your work and writing things down. Because if you write first, you get more correct answers. Your brain has time to process things. So the first thing I want to mention on here, this first bullet point up here says guidelines for using a calculator. You should always have a plan written on your paper before you touch a calculator. Have some kind of plan about what mathematics am I even doing, because if you don't have some kind of plan outlined, then it doesn't matter what you're typing in, you're gonna make a lot of mistakes. So you should have a plan, and I'm gonna show you what that looks like as we go through. If you know how to work the problem by hand, do it. It's excellent practice and you've got space right here. If you know how to do it by hand, and it wouldn't be very long or tedious to do it by hand, then just do it by hand, okay? Then you can use the calculator to check for mistakes if you want to. But if you know how to do it by hand, go ahead and do it by hand. Ask yourself this question. This is in my real life. Would it be faster for me to just do this in my head or know how to work it out? Or would it be faster to type in a calculator? Because if I'm doing something in my head that's more efficient or quick, or I know how to do it, sometimes when we get used to using a calculator, we end up doing too much with a calculator, and we'll start doing things like something like -7 plus 10. Those are integers, and those are things we should just kind of go, okay, different signs, subtracting the center one goes farther, -7 plus 10 is 3. That's faster for me to think through than to type that all in a calculator. So as we go through these notes today, there's two big things that we're going to focus on. We're going to focus on taking these situations and modeling them with an addition problem. And then once we have the addition problem, we're going to ask ourselves, is this better to do out by hand, or is it better to type in a calculator? So let's get started. Take a look at problem number 1. It says a seal is swimming in the ocean 5 feet below sea level. It dives down 12 feet to catch some fish. Then the seal swims 8 feet up towards the surface with its catch. What is the seal's final elevation relative to sea level? Sometimes when I read these problems, what I would recommend for you to do while I'm reading it out loud is annotate it a little bit. So that means you underline or mark things that sound important to you. Like this right here, 5 feet below sea level. I don't know about you, but immediately my brain goes, sea level is 0. So 5 feet below sea level, I'm going to assign that. I'm going to model that mathematically with a negative value. Below sea level, okay. Then it dives down 12 feet. That's more negatives to catch some fish. Then the seal swims 8 feet up towards the surface. That's now going in a positive direction. So I'm starting to think of like a vertical number line, assigning things. Where is 0? Where's positives? Where's negatives? Where is its final elevation relative to sea level? Sea level is 0. right? So now that I've annotated and thought through that, now I am ready to set up an addition problem. Always write down your addition problem first. Model your mathematics, model your thinking. So 5 feet below sea level, I'm going to start with a -5. And I'm going to make all of this addition since that's what we've been talking about. 5 feet below sea level. I'm going to put addition as my actual verb. That's my operation. Addition is what I'm doing. And then I'm just going to assign positives and negatives to my values. It's like a verb versus a noun. And we'll talk about that more as we move forward. So -5 feet, 5 feet below sea level, plus -12. If I keep it all addition, then I can just worry about how the seal is moving in relation to sea level and assign my positives and negatives as I go. But the operation I'm going to use, the actual math operation, is going to be addition all the way throughout. -5 plus -12, then the seal swims 8 feet up. So that's +8. And remember, if it's a positive, I don't have to do parentheses and put an extra positive symbol. That's just confusing. I can just leave it 8 means +8. Now, I'm ready to answer this. Now, back thinking towards this idea of calculators or not calculators, this is a problem that I would not use a calculator for. It would probably take longer to type in than just to count with my fingers or follow my rules. So I'm going to make a note over here that this type of problem, I'm going to make a thought bubble just for fun. This is an adding integers problem. Integers are one of those types of situations where in real life you're really going to be a more efficient mathematician. Efficient means quicker and correct more often. You're going to be a more efficient mathematician if you can deal with integers without a calculator. That doesn't mean you can't ever type them in to check things, but you're really a better mathematician if you know how integers work and you get quicker at integers. So this is a real life thing that I like to be fast at without a calculator. So now I'm going to focus on this. Same signs add, keep the common sign. Same signs add, keep the common sign. Now I still have this +8. Now I have different signs subtract, take the sign of the one that goes farther. So 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, that's 9. Take the sign of the one that goes farther. That is my integer answer. With these type of situations, you of course always want to go back and relate your answer to the question. So this said, what is the seal's final elevation relative to sea level? This -9 means 9 feet below sea level. This is me relating my answer back to the question. 9 feet below sea level. Let's try one more together. I'm going to read it out loud and we're going to kind of annotate it and mark it up. Okay, question number 2. The Tigers football team must gain 10 yards in the next 4 plays to keep possession of the ball. The Tigers lose 12, okay, lose 12 yards. That's the first thing that actually happened, losing 12 yards. Then they gain 5 more yards, and then they lose 8 yards, and then they gain 14 yards. So in my brain, to model this as an addition problem, I have to assign things. I have to decide what's positive and negative and where's 0, okay? So this seems, and usually you read the problem and you can kind of get a general feel. This definitely seems to make sense if I think of losing yards as a negative for the football team and gaining yards as a positive. So that's what I'm going to do. I'm going to say, okay, they lost 12. And actually, here's the thing on this one. Some people like to start with the 10. You absolutely can. We're going to apply it at the end of the question either way. Okay, so I'll change the colors to what I was using before. So let's focus on what actually happened to them. They lose 12 yards. They gain 5 yards. They lose 8 yards. And they gain 14 yards. Notice how I modeled the situation with addition before I even try to answer the question. Don't try to jump to the answer too soon. Make yourself a plan. Again, I'm dealing with integers, so I don't think I need a calculator for this. I'm going to gather together same signs first. I just like to do it that way. You don't have to. Same signs add, keep the common sign. Same signs, add, keep the common sign. Look, these are same signs too. Same signs, add, keep the common sign. Now I have different signs, subtract, take the sign of the one that goes farther. What does this mean in relation to this question? Well, this negative means they lost a yard. So did they maintain possession? No, they were supposed to gain 10 yards and instead they lost a yard. So we're going to say, did they maintain possession? No, they didn't. No, they actually lost 1 yard. So not only did they not gain 10, but they lost 1. So they definitely did not maintain possession. Okay, they would need at least a positive 10 answer here to have said yes to that. So I would like you guys to pause the video and try problems 3 and 4. I bet you can do these ones without calculators. Number 4, if you used a calculator just to make sure you didn't make any errors, that's okay, but I bet you can still do it without. But before you get any answers, remember we modeled the situation as an addition problem first. So pause the video, try problems 3 and 4, and then come back and see how you did. All right, let's see how you did. So just for space on this one was talking about 2 different people, Jim and Carla, so I needed actually 2 different addition statements. So I wrote Jim's over here just because I have room. You always have this column to add whatever notes you need to. So Jim descended, descended, descended. So his were all negative, so same signs add, keep the common sign. Carla started at sea level or at the surface. Descended, came up, descended, so her final resting place was still below the surface, but Jim rested at a greater depth because he's 40 feet below sea level. Now, anytime I ask you to pause and you try them, remember, if you're looking at this now, if you made a mistake somewhere, that's entirely normal. We all do that. But if you made a mistake somewhere, these notes are for future you, so make sure you're fixing them. Any mistakes that you made, go ahead and fix them right now. Number 4, just in case you're not familiar with the language of a checking account, because you guys are 7th graders and probably don't have one, and that's okay. Depositing money is a positive. That puts money into your account, and any purchases, which we sometimes call withdrawals, purchases would be negative values. So I just marked that, annotated in here. So deposits, spends money, deposits. So I did same signs add, keep the common sign, same signs add, keep the common sign, put it all together, and it's still $67 in the positive. So that means overall, from wherever this started, it didn't tell us the value it started at, but from wherever it started, it was a $67 increase in her checking account. Okay, so this page is really practicing modeling with addition, but still a lot of this on this side, I would say we could do that pretty easily without a calculator. It was all integers, so we could do a lot of that. We just had to follow our same signs, different signs rules. The only difference is there's an extra step of you have to set up the problem. Now let's continue over to page 6, okay? Let's actually read problem number 5 first. It says, for each problem, write an addition problem, then use your calculator to help you solve the problem. Let's look at this one, and then let's ask ourselves this question over here. If you just glance through, actually just glance through right now 5 through 8 and see the kind of numbers that are in those problems. And let me ask you this, why do you think these problems are more calculator friendly? Because in real life, I would say these problems are more calculator friendly, meaning I'd be happy if I had a calculator around. And probably as you looked at them, you noticed that it's not just integers. So let's tell ourselves here, there are all kinds of rational numbers involved here. So I'm going to say the rational numbers, involved could be tedious. That's a good word, tedious. Tedious means long and drawn out and easy to make mistakes. The process is long, it's easy to make mistakes. The rational numbers involved could be tedious to do by hand, or, and this one's important, or it would lead to errors, mistakes. Humans make mistakes when they do this math by hand, and that's okay. It's okay to make mistakes. But sometimes if I'm in a real life situation and I'm trying to figure out something like this, honestly, whenever I'm dealing with budgeting or doing a bunch of stuff with money, I always use a calculator. Because if I do all those decimals by hand, I'm likely to make a mistake in there, and I'm talking about my finances, so I don't want to make a mistake in there. So we're going to do the exact same thing here. We're going to set up the problem. You will set up the problem first. And then after you set up the problem, you can use a calculator to solve it if you want to. Okay, so it says you currently have an outstanding balance. That means you owe money. Outstanding balance of 234. Outstanding balance means this is a negative for you. You owe money. Credit cards, if you owe money on them, it's a negative. It says right here, that's how much you owe. You return a purchase to Target and get a credit of $67.29. That's a positive value, a credit. Credit of $67.29 back to your card. You use the card to purchase shoes. A purchase is going to be a negative. Then you make a payment of $175. Payments on credit cards are positives. When you make a payment, it's like you're giving that money back, okay? Do you still owe money on the credit card? If so, how much? I'm not going to touch a calculator yet. I'm going to set up my problem. So here I go. An outstanding balance of negative $234.76. You return a purchase. This is a positive $67.29. You use the card to purchase shoes for $34.29. Then you make a payment of $175. You can absolutely type this all in your calculator at once. Sometimes students get confused and get lost. I'm going to show you the calculator here. You can type it all in, and the thing I like about this type of calculator is you can see everything as you type it in. So I'm going to do negative 234.76 plus 67.29 plus. By the way, let me make sure you understand here. You can type the parentheses or not. Calculators will have a subtraction button and they will have a negative button. They're different buttons because they are different things. Subtraction is an action. It's a noun. It's what you're doing. Negative is a label. What? Subtraction is a verb. It's an action. I don't know what I just said, but subtraction is a verb. It's an action. It's what you're actually doing. It's a verb. The negative is the noun. It's just a label. It's describing a number. So they're different buttons because they mean different things. And we'll talk more about that as we go. So when I'm typing in like this next number, negative 34.29, I'm not using the subtraction. I'm using negative 34.29. Okay, it's not a subtraction. It's a negative label. So negative 34.29 and then plus 175. You really can just type it all in like that as long as you've got your positives and negatives assigned correctly. Now, this gives me an answer of negative 26.76. Well, what does that mean? If it's negative, it says, do you still owe money on the card? Yes, you do still owe money. You owe $26.76. If it had come out positive, that meant you didn't owe money anymore. Okay, let's try one more together. And I'll show you how to type some fractions in, because sometimes I do still type fractions in. Sometimes the fractions, it depends on the type of fraction. Like if I'm doing something like 1/4 plus 1/2, I probably don't need a calculator for that. That's 1/4 plus 2/4, which is 3/4. So you can do that kind of stuff in your head. But if I'm doing lots of mixed numbers and I'm going to have to change them all to improper and I'm going to have to find a whole bunch of LCDs, well, in that case, I might use a calculator. So for example, here, the level of a lake, we're looking at number 6. The level of a lake was 8 inches below normal. Okay, this statement right here tells me I'm going to consider normal as 0, and 8 inches below normal is a negative. Okay, so that's a negative. In May, the lake level increased, went up by 5 7/8 inches, and in June it decreased, negative, by 3 1/12 inches. In July, the lake decreased another 4 1/6 inches. What's the new level of the lake? Now, I'm looking at all these fractions. Could I do them all by hand? Absolutely. I could absolutely do them all by hand. Announcement there. Do I want to? Well, I mean, I've got an 1/8 and a 1/12 and a 1/6. I could figure out what, actually 24 goes into all those. It's not so bad, but I'm gonna use a calculator. I'll show you, but first you're gonna set it up. Don't touch a calculator until you set it up. The level of a lake was -8 inches below normal, then increased by 5 7/8, decreased by 3 1/12, decreased by 4 1/6. What's the new level of the lake? If I were going to get common denominators, I would change all of these to improper fractions. I would make all the denominators common, including this. I'd put this 8/1, make them all common, do all that. Or I could try and combine the whole parts, but that gets confusing with positives and negatives. I'm going to show you, if you have modeled it and set it up and modeled it, then it's okay to use a calculator. I'm going to show you for this calculator, and you'll have to figure out if you have a different one, but these calculators are nice because they have this ABC button right here. So I'm going to start with -8. That's just -8. Remember, I use the negative, not the subtract. Plus, okay, ready? It's going to look weird on my screen, but here's how I type it in. Mixed number, you do 5 ABC, and then 7 ABC, and then 8. That does not look like a mixed number on there, but your calculator now knows it's a mixed number. 5 7/8. Plus, here I go. The next one is negative, ready? -3 and 1/12. I just push that ABC button in between every value. And then plus -4 ABC1, ABC6. If it wasn't a mixed number, if it just said 1/6, then I would just push the ABC button once, 1 ABC6. It's not an ABC button, I just call it that. It's a fraction button. And push enter. This weird U thing is just your calculator's way of telling you a mixed number answer, which makes a lot of sense for this. So the answer that I get here is -9 3/8. This is how it shows in my calculator. This is how I write it on paper. Now, relate it back to the question. What does this mean? What is the new level of the lake with respect to normal by the end of July? Well, the fact that it is negative, it means the lake is 9 3/8 inches below normal level, by the end of July. Relating it back to the question. Okay, try the last 2 questions. You're going to pause the video, you're going to set up your addition problem, set it up. If you use a calculator at that point, it's fine, but set the whole thing up and then relate your answer back to the question. Pause, try the last 2, and then come back and check them out. Okay, I'm gonna let you look over 7 and 8, and you can pause it at any point to write it down and see how things look there. But I just wanna draw your attention first over here. I wrote some extra notes over here. You're welcome to add them if they help you. Here are the steps I really care about you writing down and seeing before you just give me an answer. Set up the problem, write it. That means you write out the whole addition problem before you type anything in your calculator, before you worry about an answer. Set it up, make a plan. That's you making a plan. If you need to, use a calculator. If you don't need to, don't. You can do it out by hand. But if you need a calculator, that's fine. And then, of course, relate your answer back to the question. So that's what we're doing with these real-life addition problems. Set it up, use a calculator if you need to, relate your answer back to the question. Feel free to pause this if you need to finish getting it written down, and then try your practice for today.